Inline and inline block tags mainly use three tags: img tag, span tag, and input tag. Images, text, and input boxes are the most important page elements. You'll often need to set margins to them simultaneously. You'll meet lots of problems when setting margins to these elements, but remember, problems we meet here are not bugs. First, we need to have a clear idea of how inline and inline block tags are being displayed in the same line. Let's try the img tag. If we copy and paste the img tag a few times, all the identical images will be displayed on the same line. But all the images are of the same width and height. Therefore, that suggests that an important bit of information has been hidden. How does the browser align these images? Let's set a different width and height to these images and see how things change. Well, as long as there's enough horizontal space, all the sibling images will be displayed on the same line. But we can also find that all images are aligned to their bottom border. The total vertical space will be decided by the tallest image. And now let's imagine ourselves as the browser. We're required to display several images. First, we check the relationship among these images. If they're sibling tags, we'll display them in the same line. Then we find out our tallest image. We put that tallest image into the browser window. And next, we expand its top and bottom border. The shaded area between the expanded top and bottom image border will be used to display the rest of the sibling images. The following sibling images will be displayed inside that shaded area. Their bottom will be in alignment with the tallest image's bottom border. We name the expanded bottom border of the tallest image alignment line. If we insert a taller image, the alignment line will be pushed downward. The other sibling images will be dragged down as well. Margin top is like a spring installed on the image's top border. The location of old contents cannot be moved by new contents. Therefore, if we add margin to the tallest image, the alignment line will be pushed downwards. As a result, other images should be dragged downward as well. We can see the result is the same as what we would have expected. All images have been dragged downward. Now let's try a more complicated scenario. What if we add margin top to other sibling images? What do you think will happen? The results depend on the total length of the image height and margin top value. When displaying these images, we need to compare their height. This time, we need to compare the total length of image height and margin top. The biggest combination will make the final decision. The rest will be ignored. Even the shortest image, as long as the spring is long enough, can push down the bottom line and drag down all its sibling images. Therefore, when one or more sibling image has got to margin top, we need to compare their total length. The biggest combination will win. In this lesson, we'll try margin bottom and find out what kinds of surprises are waiting for us. Let's first only try one margin bottom. We assign it to the tallest image. There are no surprises here. The margin bottom has pushed down the alignment line. As a result, the other sibling images are being dragged downwards. The tallest image will stay in its original place. A gap has been created between its bottom border and the alignment line. But what if we add the margin bottom property to the shortest image? Still, we need to compare the total length of the image height and margin bottom. If the total length is smaller than the tallest image's height, other sibling images will not move, but the image receiving the margin bottom property has been lifted upward. If we continue to enlarge the value of the margin bottom, when the total length is bigger than the tallest image's height, other images will be moved downward. but the shortest image has now been lifted to the very top. When you're setting vertical margins to an image, whether it's margin top or margin bottom, the total length of the margin value and the image's height is always vital. Calculate that total length first. Whoever got the biggest total length will win.